To begin post-processing when you are using a network rover, you must first make sure Starpoint is configured properly. Do this by clicking on the File button at the top of the screen and selecting Close. You will notice that most of your screen has been grayed out. Now click on the Edit Defaults button at the top of the screen, scroll down to Processing Mode, and click on Differential Positioning. Then click on Edit Defaults again, and click on Process Parameters. You should now verify that all the process parameter settings are correct. It is important to note that in order to process using a network rover, you must have Search for Base Stations checked under Download Bases and Orbits. Once all settings are configured appropriately, select the OK button. You will then want to select the Tools drop-down menu from the top of the screen, scroll down to Mapping Systems, and click on Selector. Once you verify the correct mapping system is selected, click OK. Then select the Tools drop-down menu again. This time select Options and click on the Base tab. Once you have the correct base station provider listed, select OK. Now select the File drop-down menu and click on New. You are now ready to import your data files. Do this by right-clicking on the Observations folder on the Starpoint screen and selecting Import. This will open a Windows Explorer window for you to locate the files you wish to import. Please note that the NavCom Field Units raw file and its associated DAT file must be stored in the same file folder on your computer in order to properly import all necessary files. By importing the raw file, Starpoint will read the correct antenna model, unit settings, antenna height offsets, and automatically import the associated DAT files. Once you have selected your desired field files, press the Open button. You will now see your field files displayed on the right side of the Starpoint screen when the Observations folder is highlighted. Please note that another way of importing field files to the Observations folder is to simply drag and drop the files into the folder in the Starpoint window. Once you have imported your field files, you should see an icon in the front of the file name indicating the type of file that was imported, whether it be rover, static, base, or semicon. If the file type is incorrect, you can right-click on the file and choose the correct file type from the pop-up menu. To change the predefined settings for file types, you can select the Tools drop-down menu from the top of the screen and click on Options. Then select the Data Files tab at the top of the screen, and you are able to configure which type of file should be associated with files that contain no site, contain one site, or contain more than one site. You can also tell Starpoint to automatically import coordinates from the global site database. To post-process using your default settings, select the Tools drop-down menu from the top of the screen and select Process Auto. Processing using the default settings will automatically perform processes such as downloading bases and orbits unless you import your own base, merging bases if necessary, defining combinations, processing data, creating loops, and making network adjustments. When post-processing using a network rover, Starpoint will search for the correct base station provider from the list in the Options menu. Once post-processing is complete, you will see the process summary displayed on the screen. At the top of the screen, you can select your type of process summary from a drop-down list, allowing you to choose between All Processed, which reports on everything that is processed in the project, Last Processed, which reports on what was processed the last time a process was requested, or Project, which will report on everything in the project. Below this, you will see the header, which is present in every process summary. Below the header, you will see the single point sites list. This is a list of all the points that you selected the Compute Average Single Point Position option for in the site editor. Here you're given the site name, the status after processing, the latitude, longitude, and ellipsoidal height if the current mapping system is geographic, or the X and Y and the ellipsoidal height when the current mapping system is a projected system. Below the single point sites is the baseline list. This list contains each baseline's name and occupation number, status, and solution type. Status will appear as one of three results: either Success, indicating that the solution was computed as requested, Warning, which indicates that the solution was computed but the results have not reached a high level of accuracy, or Failure, which indicates that the process has failed. Solution Type will display the type of solution that was computed. Also, you were given the vector distance between two sites of the baseline after processing, the RMS or root mean square for the vector calculated between both sites, and the RDOP or relative dilution of precision. You are also given the ratio quality factor, which is a number higher than 0 when you have a fixed solution. The smallest value for a fixed solution is 2.5, while a ratio quality factor larger than 5 means the result can be accepted with very good confidence. In general, the larger a ratio quality factor you have, the more confidence you can have in the result. The duration given is the observation time span of the baseline, and the number of satellites indicates the number of satellites which were used in the vector calculation. In the number of epochs section, you are shown the total number of epochs that covered your baseline, the number of epochs used to solve the baseline calculation, and the percent of solved epochs compared to the total epochs. Below the baselines is the trajectory section. This section is divided into two tables. The first table shows your base station. Here you are given the base station name and a latitude and longitude if you're using a geographic mapping system, or an X and Y coordinate if you're using a projected mapping system. You are also given ellipsoidal height, an undulation of the geode based on the geoid model indicated in the header section, and a mean sea level height for the base station. Also, you are shown the scale factor and central meridian bearing of your base station. Below the base station table, you are given the rover table. Here you will see the rover name and the distance between the rover and the base station. You will also see the number of epochs displayed in three categories: the total number of epochs covering the trajectory, the number of epochs that were covering the trajectory which were used to solve the calculation, and the percent of solved epochs compared to the total number of epochs. In the number of sites section, you will see the total number of sites being observed in that rover file, the number of sites with a fixed solution, the number of sites with a float solution, the number of pseudo-range sites, the number of sites that failed to be processed, and the number of unprocessed sites. The unprocessed sites are sites within the rover file that are not within the trajectory, which could happen in two cases. The first is when some sites are collected in real-time mode, either before or after the raw GNSS observation file was collected. Since there is no observation available for these sites will never be processed. The second case is when the trajectory was manually edited to cover only part of the rover. In this case, all sites that are within the rover file but outside the trajectory will not be processed. To process them again, adjust the boundary of the trajectory to match the rover. At the very bottom of the screen is the status bar, which displays the total number of single point sites, the total number of baselines, and the total number of trajectories. Right-clicking on the screen will give you the option of saving the view as a text file or printing the view.